Hi guys, how's it going? Go ahead and write this down if you haven't already. We are on 1-12 and we are talking about exponents.
Is the 2 to the 4th power a problem?
It's going to be an example we're going to look at. Yeah, so go ahead and write that 2 to the 4th. And I'm glad you said it that way. 2 to the 4th, 2 to the 4th power. That's how you would read it. Okay, what does this mean? 2 to the 4th power using multiplication. What does that mean? Like, not what it's worth. What does it mean? So that means, Matthew? 2 times 2 times 2 times 2. Okay, yes, I said that 4 times. And then, what is the value of 2 times 2 times 2 times 2? I need to know what the value is. Jimbo?
That would be 16.
16 is correct. Okay, so you need to know all those pieces of info. So how do I know it's 16? Well, because the problem was 2 times 2 times 2 times 2. How did I know it was 2 times 2 times 2 times 2? It's because of the way it's written. Okay, here's what I want you to do. We're going to label some parts because I'm going to refer to them. The 2 is called the base. Okay, it's called the base of an exponential expression. So if you write a little arrow to 2, write base. Okay. The reason I talk about base and all these terms is because I'm going to say, what's the base of this expression? You're like, what is he talking about, base? I'm talking about that big number. And what's the small number that's raised to the right side? Yes, ma'am?
Exponent.
It's your exponent. Now, this lesson is called Integral Exponents. You're like, integral? What is integral referring to?
Integer.
Integer.
Oh, it's not integral.
Yeah, it could be in a different setting, but it's talking about integers. And you're like, okay, what does that mean? That means today we are going to be dealing with exponents that are what type of number? Integers. And what are integers? If you remember, any, yes ma'am?
Any whole number in itself.
Okay, so any 0, 1, 2, 3, 4, 5, 6, 7 positive direction and their opposites. 0, negative 1, negative 2, negative 3, negative. Have you dealt with negative exponents yet?
Yeah. No.
Okay.
No.
Oh, okay. Anyway.
I don't remember it.
Wait, actually, I can't remember.
Yeah, so we'll see, and that'll be toward the end. Okay, but guys, this is what I want you to get. Okay, a lot of times I remember even growing up, even teaching my first couple of years, I would say it wrong, and I think, oh, the students, they understand what I mean. But I need to be accurate, because if I'm not, it might confuse one of you, and that's enough for me to say, I got to do it the right way. Okay. Look at what this means. This little expression means that the base is used as a factor 4 times. That's exactly what it means. So how many times is 2 used as a factor here? 4 times, right? That means 2 is being multiplied here, and we have 4 total times right there. Okay? And then you can get your number. That's not too bad. Okay, this little number right here is in what we call simplified form. So I'm going to call it simplified. It is simplified. That means that is a simple way of looking at that number. And so I'm going to ask, does anyone have like a 3rd or 4th grade sibling? Younger sibling, 3rd or 4th? Anyone 3rd? Have 3rd. Oh, 4th grade. Wow, okay.
I'm a 4th grade.
4th grader? Okay, let me ask you this question and be honest. Do you think a 4th grader would prefer to see a number like this or like this?
Like 16.
Probably like 16. You will probably get to the point where like you will realize that this is actually easier to deal with, but for now, simplified form just means just write it like a normal number, okay? So I might ask you, write it in simplified form or simplify it. I want that number. Or I might ask you something else. Okay, go ahead and write this expression down, ... So that means to be continued on that thought. Let's go back to 3 to the 3rd. What's a special way of saying 3 to the 3rd power? There's another way you can say it a little bit more special. Kaden? It's so special, it's like, oh wait, what was it?
3 times 3 times.
Okay, that is what it means. I'm going to write that down because you do need to know that. Stella up front?
3 cubed.
3 cubed. Have you heard of that word, cubed? So if you have an exponent of 3, okay, regardless of the base, so it doesn't matter what this base is, but if you have an exponent of 3, you could say something cubed, okay? There's a reason why we use cubed. It's not just random. You know what? Let's just use cubed for 3. There's a reason. I don't have time. It deals with geometry. But anyway, 3 is used as a factor how many times?
3.
What's the simplified form?
27.
27, because 3 times 3 is 9, and 9 times 3 is 27. Okay, so you guys get that? Chris, what's the base of this expression? 3. Mary Addison, what's the exponent?
3.
By the way, if you said 3, you were probably correct no matter what I asked you so far, right? 3 and 3. Okay. What's the simplified form? Yes, Tyler?
27.
What's the expanded form? I haven't brought that up, but I'm like, wait, which one is it? Stella back there?
3 times.
Yep, expanded form. So I have exponential form, standard, or excuse me, woo. I'm going to write this down because I'm going to mess myself up. Exponential form. Okay, that's exponential form. I'm going to ask you sometimes, please write your answer in exponential form. I need an exponent. Sometimes I'll say, not very common, this middle way, expanded form. Why do you think we call it expanded form?
Because it's really long.
Yeah, they expanded the problem, so they made it long, multiplication. And then this last form, it is simplified, but we technically call it standard form. Okay, so we have 3 forms you need to know. By the way, you don't have to write expanded form, but you at least need to think expanded form, right? So you're like, what's 3 to the 4th? Well, what's 3 times 3 times 3 times 3? Then you can figure it out. Okay, sorry, Kaden, what's your question? Or if you still have it. Oh my, I'm so sorry, I talk too much. Swivl, you know me better. By the way, we've shared many hours together, and he knows. He knows what's on my mind. Right, Swivl? Okay.
He knows what's in you. Bum, bum, bum.
Okay. Oh, you know how to deal with expanded form, exponential form, and standard form. Like you get that, but we're gonna have to go further than that. Okay, write this problem down. What kind of problem is it?
Negative.
Multiplication. So that's what I refer to. And yes, you have exponential forms. Okay, so I want to know what this answer is in exponential form. And you're like, what do you mean? It's already in exponential form. You see how you have 2 separate expressions? Combine them. Make them 1. So here's how I'm going to do it. How many of you know what negative 2 to the 3rd means? What does negative 2 to the 3rd mean in expanded form? I want expanded form. So please don't give me the wrong thing. Yes, ma'am?
Negative 2 times negative 2 times negative 2.
All right, so that's what expanded form means, right? What does negative 2, whoa. What happened, how do I read this? I can read this negative 2 to the 2nd, but a special way of reading this one is negative 2 squared, right?
Squared.
Do you guys notice squared? What shape are you thinking of? Square. And then cubed, what are you thinking of? Cube. And you're like, where in the world? Do you want to know where they got that from?
Yeah.
Of course you do. Oh, okay, ready?
2D.
Yeah, 3D, 2D, that's part of it. Okay. If I had a square, pretend this is a square, and I didn't know the side length, I called it S, how would I find the area of this square? How would I find the area?
Length times width.
Okay, and they happen to be the same thing, right? Length and width are the same thing. So I would say S times S, which is in exponential form, S squared, right? That's squared, right? That's the formula for the area of a square. Okay, and then what do you think I get a cube for? All right, here you're going to test my knowledge, or my ability to draw. Oh,
Wow.
we'll pretend that's a cube. How would you find not the area of a cube, but the volume of a cube?
Length times width times height.
Length times what? That's okay. That's cool. Swivl, did you get that? That's an awesome meme. Okay, anyway. S, length times width times height. Do you guys agree that's volume?
Yeah.
So if you had a cube, the length, the width, and the height are all the same. So you would say S times S times S, which is in exponential form, S cubed. So squared, cubed. So guys, some people say, that doesn't make sense. And I say to them, it doesn't make sense always to me, but it still makes sense. And there's a justification. So please don't think we just randomly think of these. I used to think that until someone told me, what? And then you figure it out. Okay, yes, ma'am.
So like for -2 times -2 times -2.
Yep.
So when you do two negatives, is it like our previous?
Ah,
It makes
you,
it positive?
so does multiplication less than 1 dash 8 or 9 apply to this?
Yes.
Good question. Hold it. Hold it. Okay, what's -2 squared? That means an expanded form, -2 times -2. Okay, so I'm just writing it all out. Okay, let's do it one way and then let's do it another way. I want the simplified form. I want the simplified form, standard form. So, ready? What's -2 times -2? Positive 4, right? A negative times negative is positive. What's positive 4? Remember what this is. What's positive 4 times -2? -8, right? So this right here is worth -8. By the way, what's -2 cubed?
-8.
Okay, so you do use the rules. You still use the rules. All right, what's -2 times -2?
4.
Positive.
Positive 4. Because a negative times a negative is positive, times.
Wait, would that be positive 8 then?
A negative times a negative. So negative times a negative is positive. And what's a positive times another negative? Negative. So it kind of went back and forth. And then what's -8 times 4?
Positive. -32.
Okay, so that's what this is worth in standard form, right here. Standard form. Okay. Are you guys okay with standard form? You could just find one, find the other, multiply the two. I want it sometimes in exponential form only. I don't want it in standard form. I want it in exponential form because I'm picky. Yes, ma'am.
Wouldn't exponential form be 4 to the 5th power?
4 to the 5th power. So 4 to the 5th power means 4 times 4 times 4 times 4 times 4. So like, ready? 4 times 4 is 16, times 4 is 64, times 4 is 256, times 4 is like 10 something. I can't do that in my head. Okay, anyway, it's big. It's 10, 24. Okay. I'm going to go back to this right here, and I'm going to show you how you can figure it out just from looking at this. Okay, how many times, guys, is -2 used as a factor? 5 times, ready? So isn't this combined -2 to the 5th?
Wouldn't it be the 6th though?
No, it's
That's okay. You can think. It's okay. And you can interact with me. I'm cool with that. But do you guys get it? It is -2 to the 5th? You're like, I don't think so. All right, ready? Let's do that. Watch my fingers. Ready? What's -2 times -2?
4.
Positive 4 times -2.
-8.
-8. I can't do this. Ugh. Okay. What's -8 times -2?
Positive 16.
Positive 16. Ugh. Ow. Okay. And then what's positive 16 times -2? Negative 32.
Wait.
Do you remember? Let's go back.
How do you go negative with fingers?
Can you do it? Yay! That's what it was. It hurts to go negative with fingers.
You can put them inside out and cut them off.
You didn't hear that, did you?
There's
Okay.
a little boodle there.
Okay, guys. Let me do this for you. Let me do this, guys. You can solve this and you can make this in exponential form by just writing everything out. You could do that just like we did here. Or you can follow the law.
What? Oh, the letter of the law.
The letter of the law.
Maybe.
And I want to make sure I write this law down correctly. Law of exponents for multiplication. Okay, this is a law. Now, how many of you agree that, or maybe you don't know this, but how many of you know that the law can sometimes be very, very technical? Hitherto shall twine the days. Guys, if you read the actual law, it's very, and I just gave you the words I can read. Some of them are like, I don't even know what they're saying. The law is very technical. You know what's going to make the law easier in math? I could write the law out in words. Hitherto, therefore, wherefore, albeit. Okay, those are all the technical words I know. I'm going to use algebra. Okay. Here's the law. It's like a sign. Instead of saying, and by the way, here's a law for the road. You know a stop sign tells you to stop. You know what stop means?
No.
You are not moving anymore. That's what stop means.
To end progress.
It means to not move anymore. You're not moving. Because you're talking about motion and objects in motion. Yeah. But it could mean that. Okay. So a stop sign just says stop, and you're like, what does that mean? It means not to move anymore. Imagine if they said in every sign, your vehicle should not be moving anymore at this point. Right? That'd be a lot. They just say stop. Here's my version of the law of exponents for multiplication. Ready? A to the m power. A to the m power. You're like, What does A stand for? It stands for a number. I don't know the number. It's okay. And what does m stand for? Another number. I don't know. What's the base?
A.
What's the exponent?
M.
Cool. So you know that.
Why A?
You really could have used any, but we just picked A and M. A to the M. Okay, and then A to the M times A to the N. Now, what does A stand for? A number, which is the same as A, right? These two are the same. And M and N may or may not be the same. It just depends. But I know A are the same. They got to be the same.
M and N can't be the same.
They can be the same. Yeah, they're literally, like they really can. A has to be the same.
Yeah, A has to be.
But A and M and N could be the same.
M and M.
Yeah, I'll show you. We'll show you an example. I know that they gave you different letters, but you could say, like, for example, M is 1/2, and then you can say N is 0.5. It's the same thing, but you said it differently, which is fine. Yes, Kate?
So, so the second number, could n be m, and it wouldn't mean the same thing?
If M and N were the same thing, it still works out.
But what
But-
if it's a
To the M?
times a n? Would that be the same?
You do the same thing. And here's what you do. Ready, guys? Here's the law, and here's the shortcut. A to the M times A to the N is equal to A to the M plus N. Write that down. You just gave me all the scenarios for this type of problem. You're like, that doesn't make sense. Okay, ready, guys? -2 to the third power times -2 to the second power equals -2 to the, what's 3 plus 2?
5.
There you go. That's the law. Right? Isn't that what you did? Is that what you did? So instead of writing it all out, just add the exponents. But here's the rule now with words. Because the words do mean something. Because again, stop. This is what stop means. Ready, Swivl? I'm going to stop. So here's, and I taught students how to drive. So okay, go ahead and stop.
Why are you?
When have I stopped?
You haven't.
I have, but I'm going super slow.
But you're
like super.
You're still stopping every other second.
Super slow. Okay, have I ever fully, completely stopped?
No.
I've gone really, really slow, but what's the definition of stop? It means to be completely without motion. Boom. That's a stop. So I'm going to describe this with words so that you know exactly what I mean. When you are multiplying two numbers with the same base, you guys remember what base is?
Yes.
So what's the base of both of these? A. Add the exponents. That's what I mean. If you're multiplying two numbers with the same base, add the exponents, which is right here. Did you guys get that? Yes, ma'am.
So like you don't have to like write.
Oh, time out. Don't write that.
Answer. You just have to write it like that.
If I say just write exponential form, yeah, leave it like that. If I say in simplified, now you have to give me what's -2 times -2 times -2. Times -2 times -2, just to make sure I said it right.
I'm second.
Okay, let's go. Okay, Stella?
So that's just if it's an exponential form, not solving.
Yeah, if it says solve it, you could do it. You could just figure out what that is, then you just get the final answer.
Wait,
Oh, sorry. Yes.
So this isn't solving the problem.
It is. It's making it easier because we're not saying solve. We'll say simplifying. So instead of having two expressions, we only have one. So that's making it simpler. So you could say by definition simplify, and then if you wanted to find the actual number, you would get -32.
And for this, it can only be the same number.
Exact same base. Has to be the same base. Let me write a problem, then I'll get your questions so I can get the other ones working. All right, let's go here. 7 to the 4th times 7 to the 5th equals, I wanted an exponential form. So you need to give me a base with an exponent, whatever it is, that's the answer. Okay, but questions while we're doing that? Yeah, Jimbo?
So I might not have caught this given earlier question,
Uh-huh.
but if there are two different bases,
Mm-hmm.
like if
Like that
say,
problem I almost showed him?
-3,
And -2. This was -3, this is -2. Yep.
do you multiply them and then just put the
Good question, good question. What do you do with those type of situations? All I've told you guys is if you have the same base, add the exponents. I didn't bring up different bases because you don't do that. But what do you do? We'll find out. Okay, anyone know what 7 to the 4th times 7 to the 5th is in exponential form? Chris? 7 to the 9th. Do these two numbers have the same base?
Yes.
Are they being multiplied?
Yes.
What do you do with those exponents? Add them. 7 to the 9th. That's it.
But you're not solving.
Remember, what are we trying to do here? Simplify. And later we will, but that's 7 times 7 is 49 times 7 is, yep. And then you have to do it a few more times. So I'm not asking you to do that. Sorry?
So if they're different numbers, you can't do that? Like if they're different numbers?
Try it. Good question. It's your two questions, Jimbo, and yours, Caroline. Mary Aston, try it out.
Do you want it in exponential?
Yeah, and the instructions will say in exponential form or simplify it. Exponential form means write it 7 to the 9th. Simplified would have been, what is 7 times 7 times 7 times 7 times 7? So I'm not asking you to do that every time because those numbers are huge. Unless you want to do it? Oh, well, bummer. Okay, anyway. Okay. Does the law apply to this problem?
Yes. No.
Why does the law apply?
Well, if you like,
They're not the same.
multiply.
Because you are multiplying,
Yeah,
but are you multiplying the same base?
No.
The law doesn't apply. You will not get 30 to the 4th. That's huge. That's not what that's worth. You will not get 5 to the 4th. And 6 to the 4th? Nah. Nothing. You know how you figure this one out? What's 5 squared? What's 6 squared? And then you actually multiply that. There's no way to use a law in this problem because there's no like bases. But I'm not going to give you these because they're not following the law. Okay, I just wanted to throw it out because you can't do it on those. Yes, sir.
5.5 for both of them, would that give you the same?
You can actually make them have the same base. You can force them, but these would be either, dare I say, fractions or decimals, and you can do it. But we're not doing that. That's like algebra 2 later on.
2 later.
Huh. Write this one down. That's not multiplying, is it? It's dividing. Okay, so good. Some of you are saying, yeah, it is if you did something good, but let's just look at it as dividing because most of you are saying that's dividing, that's not even multiplying. Okay. If when you're multiplying two numbers with the same base, you add the exponents, what happens when you divide numbers with the same bases? You do what with those exponents? What do you think? Subtract. And you're like, huh? Okay. Ready? I'm going to show you the way to do it. I'm going to give you the law, and then I'm going to give you the justification for the law. I'm not making up the law. I don't make up the law. I enforce the law.
Mr. A is that gives you like a law enforcer.
There you
Mr.
go.
A the math cop.
With glasses and a hat and longer hair. Okay, anyway.
Big bushy black mustache.
There you go. I can do that. Okay, yes. The answer is 6 to the 2nd power.
What?
Okay? Okay, I'm going to skip the law for now. I'm going to show you how you can actually prove it. Okay, ready, guys? Okay, 6 to the 5th. Doesn't that mean that 6 is used as a factor 5 times?
Yes.
Okay, so ready? I'm going to do this. You don't have to. You can do this on your paper, but you won't have to do this on your homework. This is the long way, right? Isn't it 6 times 6 times 6 times 6 times 6? Yes, of course. Okay, what's 6 to the 3rd mean?
6 times 6 times 6.
Awesome. Okay. Do you remember I could do this?
What?
And then I could do this?
Whoa!
And I can do that? You realize I can do that? Okay. So what's 1 times 1 times 1 times 6 times 6 in exponential form? exponential form,
Oh,
6 to the second, right? There's only 2 of them. And what's 1 times 1 times 1?
Nothing.
1. What's 6 to the second over 1?
6.
It's 6 to the second. And that goes back to that.
Whoa.
It has to work, and it does work. Not making it up. Every single you give me a problem, Kaden, and it has to work. And if it doesn't, the law has been broken. And we will prosecute, oops, wrong word, prosecute the offender.
Mr. A, I have a problem.
Okay, I have Caroline. I think her hand has been up for a while, then I'll go to Ruth. Yes,
Can I
ma'am.
go to the restroom?
What a way to transition. All right, is it emergency?
Yeah.
You may leave. Okay, Ruth.
What about
Oh.
59 million to the 75th over 59 million to the 37th?
So 75 minus 37, boom, that's your answer. 59 to that. It would work. It would work. And by the way, Ruth, you would break the calculator by trying to do this because that's huge.
Now we gotta try it.
Not on my calculators. Okay, yes, Henry?
What if we did 6 to the third power over 6 to the fifth?
Oh, okay, hold it. Yes, we will do that. Let's get to the law. The law of exponents for not multiplication, but okay, let's look at the law. How would the sign look on any one of these problems? How would you follow the law? Okay, I would write it a to the m power. By the way, you could say that a to the mth. And you could say over or divided by a to the nth power. Emphasis on th.
Why are we mimicking our teacher?
Yeah. There's another one. Okay, how would I write it in algebra? Do you guys know how I would rewrite it? So Jimbo knows. Let's see. All right, listen up. I'll wait for them. I'll wait. Yeah, go ahead.
Me?
Yes, sir.
So I would write it A, M to the M minus the N.
A to the m minus n. That's how you do it. All the problems work that way. Now listen to me right now. So I see Stella looking at me, so I'm going to ask you in just a bit. Ready? Because she was looking. It always means this exponent minus this exponent. Do you understand me? It's always this minus that, no matter what. Hey, I'm going to ask her again. Don't forget. Okay, but that's the law.
So it could be like a negative.
Wait, how do you have a negative exponent? Like,
Go ahead and do it. Simplify this. Excuse me. Write it in exponential form. I want to use my words correctly. Okay. What did you get, Aiden?
is the answer just 1 for the whole thing?
No.
I don't know, right? Wouldn't it?
Exponent is 0. It would be 1.
No, it's just 6.
Okay.
0.
No, 6 divided by 6 is 1.
You don't divide it.
6. We're
You keep the same
I'm so okay. Keep that thought. Keep those thoughts. Okay. How many of you agree that it would be 6 to the 5 minus 5?
Yes.
And that equals 6 to the 0th.
Which is
It's a strange way to go by
Which
the.
is you have to write 6 to the
If I said exponential, yes, 0th. Okay, now listen to me. Ready? I'm going to give you this, guys. What is 6 to the 5th over 6 to the 5th? What's it worth in standard form? It's worth 1.
No, 0. No. Because wait, if you have 6, 0.
This is true. Okay, can we do this, guys? Ready? Give me one chance to prove it. Okay, 6 to the 5th is 6 times 6 times 6 times 6. All right, and then 6 times 6 times 6 times 6 times 6. Okay, you guys get it? That's a nasty looking little 6.
Get it now. I'll give it.
Yep.
Yes, it makes
Yep.
sense. I'm just looking in my head.
What's 1 times 1 times 1 times 1 times 1?
1.
What's 1 times 1 times 1 times 1?
1.
What's 1 over 1?
Mr. A.
Okay, guys, write this down somewhere. Write this down right now. This is a definition. Any number, and I mean any, to the 0th power is always equal to
0.
1.
1, bro.
1. Always. Definition. That means if I have 3 to the 0th, what is that actually worth? 1. Negative 2 to the 0th power is still worth 1.
Wait a second.
Yes, ma'am?
What if it's, nope.
Yeah. Negative
Uh-huh.
1/5.
To the 0th? 1.
What?
Thank you. Yes. Because that, I would draw it out, but I don't want to confuse people, but it is by definition.
Would you
To
take
the-
points off your question? Write it as 1 or
Okay, great question. Listen, if I said write this answer right here in exponential form, which one must you put?
Oh, yeah.
6 to the 0th. If I said simplify it or write it in standard form, 1. So you got to be able to do both. That's a good question. Okay. Oh my, a lot of questions here. Yes, you've had your hand up for a while, Sam.
Okay, so
So,
6 to the 5th power
uh-huh.
is going to be a high number.
Very high.
6 times 6 times 6. Yeah.
Exactly. Good.
Both of them are going to be like that.
And they're both going to be the same, right? So what's any number over itself? It's 1. Yep, you're right. Got it. Good job.
Not bad.
Okay, yes. I want someone to work it out while you guys are doing it. Okay, yes, Ruth. Work this one out. Yes, ma'am.
Okay, so if you have 6 to the 3rd,
Hmm?
you'd be 6 times 6 times 6.
Yes.
Which means if you have 6 to the 0th, that means it's 6 0 times,
Exactly.
right?
Yes. So what? And here's great question. Here's the thing. Usually when there's no number present, I don't want to say this. Oh, I don't want to say this. But it's technically there's a 1 there. It's a unit 1. It's there. Yeah. In fact, can I give you a reason? Remember, one of my favorite numbers is 1 and the other one's 0. Okay. They in the Greek times, ancient Greek times, they actually had a cult that worshiped the number 1. The number 1. And they don't write a 1 and bow, oh mighty 1. No, they just try to look for 1 in everything. There's 1. See, 1 person. That's good. 1 person. 1. Whatever they can find in 1 is good. And they worship that. That's how important 1 was in math, and they actually worship it. That's too far. Don't worship 1. Worship the creator who made 1. Okay. Yeah. Okay, Stella, I think you were.
Is that how they made, like, we are one with, one with the wind or one with the grass?
I would say that cult might like that. We're not 20 in here or 21. We're 1. We're 1. And so we act that way. Which, guys, is not totally off. In Christ, you are 1. But that's in Christ, not just everybody's just 1. No. Yes. Okay, Caroline. I'm gonna keep going. I'm gonna help you out with that.
So when you do the subtraction exponent, that would just be 2, right? Because
Okay, hold on.
even though 2 is in front of it, that would still be 2, or like.
My question back to Stella.
Yes.
Remember what I said?
Yes.
It's always what?
Oh boy.
What do you subtract?
Oh, the exponent.
Yeah, but what?
Wait, what's it called? Hold up.
I wanted, okay.
2 minus 4.
It's always going to be,
Exponent.
it's always going to be this exponent minus that one. Always. So this would be 4 to the 2 minus 4, which is actually 4 to the negative second.
So now there's negative 2 of them.
Wait, I got 2 and to the negative second. Seriously? But you have to borrow.
No, so you have the same base, right? So your answer is going to have that same base, just change the exponents. Now, guys, you're doing pretty well. I love these questions, guys. I want you to struggle through it, but it's the first time. Can I do another proof here? What in the world does that even mean, okay? I'm going to tell you this right now, and you need to either write it down or commit it to memory. 4 to the negative second is not a negative number. Okay, this right here, this is not worth a standard number of negative something. It is not. It is worth this. You ready? 4 times 4, right? That's 4 squared. And 4 times 4 times 4 times 4. Okay, ready, guys? Let's do this again. That's a pair. That's a pair. Okay, so what's 1 times 1?
1.
What's in exponential form 4 times 4?
16.
Oh, sorry. Yeah, 4 to the second, which is 1 over 16. Yeah, right? Okay.
Why do I not like that?
Do you guys notice that from this same problem, I got 4 to the negative second, and I got 1 over 4 to the second? Okay. This is what I want you to do. Circle this little negative. Everyone needs to do this. You must. No, do it. Yeah, don't do it. Yeah,
That's so hard.
Okay. This little negative sign for the exponent means a key word that we have talked about.
Reciprocal.
It means reciprocal. Okay? It means reciprocal. It does not mean negative. It means reciprocal. And you're like, wait, what? I thought it was a negative. It is a negative sign, but if it's in the exponent, it means reciprocal. And you're like, yes, it does. Okay, ready? Before I get those questions, let me write you a definition that will help clarify this. A to the negative m, okay, right? You see the negative exponent, right? Is equal to, well, let me ask you this. What's the reciprocal of A? Okay, think A. You're like, wait, isn't it A over 1? Isn't that really A over 1?
No.
A is A over 1?
Wait,
Yes.
So it means 1 over A to the positive m. Definition. Now, let me tell you this before we keep moving on. I'll get these questions. I will. I'll get to your questions. I've taught a few lessons in my math career. Several times, once every year or twice every year, depending on the class. And there are some questions where, like Matthew, he's doing pretty good. But some where, like a guy like Matthew, a good student, looks at me and he's mad at me. He's mad. He's like angry at me. Not today, Matthew. Oh, wait. Camille, normally I would say very easygoing person.
Yeah.
But except when they tell me differently. Okay, but Camille, normally easygoing in class, is looking at me and saying, no. And even Stella back there, who's normally smiling.
No.
Okay, and even Jimbo, who is a very, very good participant in class, is no longer a participant. He's like, I'm done. I'm saying that some of these lessons are like that. This lesson right here, people are like, no, I don't like it. It's bad. It's not right. Okay, give me some time and give yourself some time. How many of you do not get this yet? That's okay. It took me, I used to teach it in different ways, and I used to be like, the kids were half confused, at least half. And now I'm like, I need to think of it like reciprocal.
I get a little bit of it.
I get
that just.
So we need to practice. Okay, go ahead and write this problem down and try to try to write it in exponential form and use your negative exponent. Just keep it with the negative exponent. It's going to have a negative exponent. And then I'll tell you what to do next. Okay, I'm going to go Ruth, then Caroline. Ruth?
Can you repeat all that again in English?
No.
Oh, Swivl can. Check him out. He will tell you exactly. I don't even know what I said. Don't forget to like. Okay. Okay, Caroline.
Get that notification.
I don't know what I said. I mean, he will know exactly. He will even know how I said it. That's what's cool about Swivl. He gets me.
Being louder than everybody else.
I know, that's the point.
Okay, go ahead,
I
Caroline.
understand how you write it and stuff, but I don't understand how you can with reciprocal and stuff. If reciprocal means opposite.
Okay, reciprocal means inverse.
Oh.
Which also means opposite.
No. Reciprocal means inverse.
I thought inverse means then what does reciprocal mean? What does inverse mean?
Reciprocal. It means reciprocal, which is cool.
Spider coming
I
down
just
the
don't
side of light.
understand how
Or something coming down.
Okay, let's try it. That's okay. If it bites me, I might get powers, and I'm cool with that.
You're gonna become Spider-Man.
And we will throw you into quarantine.
That's
We'll throw you into quarantine, drain all your blood, and inject you.
All right, I'll wait for you guys. Now listen, I'm going to give you a little encouragement here. With the other class, they were doing well. They struggled. They struggled, but they stayed with me. And at the end of the class, it said no homework. No homework tonight. So I want to do that for you guys, but keep asking questions. Just don't get too out of line. Okay, yes, sir.
So what I was thinking about,
Stay with me. Last problem. Go ahead.
Alright, so
Write this down when I write.
like at the beginning of the year, you're talking about like infinite decimals
Uh-huh.
and infinite whole numbers. So with normal exponents, you're like kind of, if you're for 2, for instance, you're doubling it every time. But for negative exponents,
You're cutting it in half.
every time.
Exactly. So here, guys, that's good, Jimbo. Did you guys get 7 to the negative third? Okay, now hold on. That's good. Can you write its reciprocal?
Yes.
7 and 3. It's 7 and 3.
But how do you write it?
1/7 to the 3rd power.
So do you have to write it like that every time?
Yes. You need to write like this for now, and then we're gonna get to this. We're eventually get to that. Bye bye, Swivl. Uh oh.